Welcome. Today's video we're talking about types of angles. The slide deck for this is available to you, so if you would like to make your own copy of the slide deck and take your own personal notes on there, you can do that. You can print the slide deck kind of like I did here and take notes on paper, or you can take notes in your composition notebook. However you would like to take notes on this, I would like you to at least take notes on some of the key definitions and examples as you follow along the video. All right, so today we're talking about types of angles. So the first thing I wanted to do was I wanted to remind you of some of the angle classifications we've talked about. So an acute angle is an angle between 0 and 90 degrees. A right angle is an angle that measures exactly 90 degrees. An obtuse angle is an angle that measures between 90 and 180 degrees. And a straight angle is an angle that measures exactly 90 degrees. The first thing we're going to talk about is the angle addition postulate, and this is very similar to what you've been doing with segments when we do segment addition. So this postulate states that if we have two adjacent angles, so adjacent means next to, and we're going to have an example of that in a little bit. If we have two adjacent angles, we can add up their measures to find other unknown angles. So for instance, if I have this picture over here, the measure of angle RST, so I go from S to T, so this angle here plus the measure of angle TSV, so from T to S to V, this angle here is going to equal the measure of angle RSV, so from R to S to V is this whole angle here. Okay, so let's look at some examples. So our first example asks us to find the measure of angle ADC. So ADC goes from A to D to C. And so if I look at the picture, I have two angles, so I can say that the measure of angle ADB plus the measure of angle BDC, this one over here, is going to equal that whole thing. That's going to equal the measure of angle ADC, and then I can go through and put the numbers they give me. So they give me that angle ADB has a measure of 21, and the measure of BDC is 63. So then I can add those together and find that the measure of angle ADC is going to equal 84. Okay, great. Next, if the measure of angle SRU, so SRU is going to be this angle here, is 2x plus 1, and the measure of angle URT, so U to R to T, this angle here, is going to be x plus 2, find the measure of angle SRT. Okay, so measure of angle SRT is right here. So the measure of angle SRT is going to equal the measure of angle SRU plus the measure of angle URT. And so then I can go through and plug in the expressions they give me. So the expression for angle SRU is going to be 2x plus 1. And the expression for angle URT is x plus 2. So then I can combine my like terms. So I have 2x plus x is 3x, and then 1 plus 2 is 3. Now if they had given me another measure, so maybe they had told me something else about this, like maybe they gave me a specific measure for one of those angles, I could probably solve for x and find the actual measure of angle SRT. But for this particular problem, I don't have enough information. All right, let's move on. So next thing we're going to talk about is special angle pairs. Big reminder, pair equals 2. All right, so a lot of students forget that and they think some of these can be 3 angles or something like that. Nope, pairs, 2. These are pairs of angles, all right? So the first one we're going to talk about, I already mentioned before, is adjacent angles. And adjacent angles are angles that share a common side and a vertex. There are no gaps or overlaps between adjacent angles. So here we have two examples of adjacent angles. So angle 1 and angle 2 are adjacent. And we see that they share a vertex right here, and they share a common side, this ray between them. Okay, and same thing with 3 and 4. So 1 and 2 make what we call a linear pair. We're going to talk about in a second. And 3 and 4 don't make a linear pair. Okay, so then we can also see that angle 3 and angle 4 are also adjacent. Okay, adjacent just means next to. If I could spell correctly. Okay, so next to. That's the big idea here. Okay, they're next to each other. All right, next definition, complementary and supplementary. So complementary angles are a pair, remember that's 2, whose sum is 90 degrees. So they don't have to be next to each other, but here's an example of where they are next to each other. So if my angles are adjacent, then together they're going to create that right angle. So these are adjacent and complementary. Okay, and over here I have 2 separate angles. They are not adjacent. They're completely not touching each other, but I have their measures, so I can tell that they're complementary because 40 plus 50 is going to be that 90 degrees I'm looking for. Okay, and same thing with supplementary. So supplementary are a pair of 2 angles whose sum is 90 degrees. So here I have angle 3 and angle 4 are going to be adjacent and supplementary. Okay, so they're next to each other. We can see that they are supplementary because they create a straight angle, which we know is 180 degrees. Or if I'm given their measures, like I am in this other pair, I can also tell that I have a pair of supplementary angles. Next special angle pair we're going to talk about is a linear pair. So here are 3 examples of linear pairs. And linear pairs are 2 angles that are both adjacent and supplementary. So they're next to each other and they have a sum of 180. And so I can see that in a picture because they create a line when they are next to each other. So here angle 1 and angle 2. Here these might even be right angles. If I have 2 right angles next to each other, then those would be a linear pair. Or I could have, another set of angles over here, and they create a line when they are next to each other. So that's a linear pair. Linear line, remember that. Next, vertical angles. So vertical angles you're going to be working with a lot. This is very exciting. Vertical angles are pairs of opposite angles created by intersecting lines. So in my picture here, angle 3 and angle 4 are vertical angles. Okay, so there's one pair. And then my other pair of vertical angles would be angle 1 and angle 2. All right. And so I have a question for you. I want you to ponder this. I want you to write this down wherever you're taking notes. What do you think is true about the measures of vertical angles? So if I have a pair of vertical angles, what do I know about their measurements to each other? Are they congruent? Are they complementary? Are they supplementary? Are they a linear pair? Are they adjacent? Tell me something you know about vertical angles. What do you think? So take a moment, write that down. All right. Example 2, in the diagram, identify pairs of numbered angles that are related as following. Adjacent angles. So these are angles that are next to each other. So we have a ton of angles next to each other. So I might have, for adjacent, angle 1 and angle 5, right? They're next to each other. Maybe I have angle 1 and angle 2. Maybe I have angle 2 and angle 3. Maybe I have angle 3 and angle 4. Guess I should put commas between these so it's easier to separate. And then angle 4 and angle 5. Okay, those are all my adjacent angles. Complementary angles, remember these are going to be my 90 degrees. So the only thing I know really is that I have a right angle right here. So that would give me that angle 2 and angle 3 together create a right angle. So those would be my complementary angles. We actually have another pair, which we're going to talk about here in a second. and it goes back to that question I just asked you about. So another pair would be angle 2 and angle 5. And we'll get back to that in a second. Supplementary angles, remember these are angles that add up to 180 degrees. And it's a pair. So if I think about the lines I have, so here's a line that goes all the way through. And if I want two angles that add up to that line, I get angle 3 and angle 4. And if I look at this line here, so let me erase that line. And if I look at this line here, I can see I get angle 5 and angle 4. And wouldn't it have to be true that angle 5 and angle 3 have to be the same measure? If they both add up to 180 with angle 4, then angle 3 and angle 5 have to be the same, which is why they're both complementary to angle 2. So there we go. Vertical angles. All right, let's look at these vertical angles. Okay, vertical angles are where two lines intersect. So if I make my two lines, so this is a ray, the one that goes straight up between angle 1 and angle 2. So I'm not going to think about that one when I talk about my vertical angles. All right, because it doesn't go all the way through. So if I look at this, I have two sets of vertical angles, one here, so 3 and 5. And my other set is these two angles right here, so 4 and then the sum of 1 and 2. But since 1 and 2 isn't like a labeled angle, I don't get to write it down. Okay, and then my last example is a linear pair. So it just asks for one linear pair. So if I look at a line, I can do 5 and 4, or I could also do 4 and 3. Okay, so angle 5 and angle 4, or angle 4 and angle 3. Great. Making conclusions. So when we look at a diagram, if it looks like you can assume segments are collinear, an angle is a straight angle, angles are adjacent, angles form a linear pair, there should be an M there, then we can assume those things. If it looks like it, sure, those things are true. Only if it's marked can you assume the following. So segments are congruent. If they look congruent, unless they're marked, you can't assume that. Angles are congruent, same thing. Segments are perpendicular, angles are right. Okay, those are all things that need to have those special markings on them, all right, in order for you to know that those things are true. Example 3, what can we conclude from the diagram? Okay, so let's look. The thing that's marked right away is angle 1 is congruent to angle 2. Okay, because it has those little arcs that tell me. I can conclude a whole bunch of adjacent angles, right? If angles are next to each other, then I can conclude they are. So that would be 1 and 2, 2 and 3, 3 and 4, 4 and 5, 5 and 1. Okay, I'm just going to put a lot. Okay, you don't have to list all those. I can conclude that, let's see here, what else could I conclude? Let's look at my lines. So if I have a line here and a line here, I get that angle 4 and angle 1 are vertical. Okay, so I got a pair of vertical angles there. I have 5 and 1 are a linear pair, and 5 and 4 are a linear pair. All right, looks like that is about all I can conclude. I might be missing something, but I'm pretty sure I'm not. Angle 3 looks like a right angle, but remember, I'm not allowed to conclude that unless it's marked, and it's not marked, so I can't conclude that. Yeah, I think that's it. All right, next. Example 4, can you make each conclusion from the information in the diagram? Explain. So the first one is segment TW congruent to VW. So TW congruent to VW, yes. Okay, it's marked. B, PW is congruent to QW. The answer is no, not marked. Okay, so you see the difference? We have a little tick mark between T and W and V, but we don't have the tick marks between PW and WQ, even though it looks like it's congruent. And if I got out a ruler, they probably are, but if they're not marked, you can't assume that. The next thing is TV perpendicular to PQ. Okay, so let's look at that. So TV perpendicular to PQ. They look perpendicular, but they're not because it's not marked. Okay, no, not marked. TV bisects PQ. Okay, let's talk about this. So TV, so this is the thing, is this cutting this in half? That's what it's asking. Okay, so the first one is the thing that cuts, and this is the thing that is in half. Okay, so it's asking me, is that cut in half? And the answer is no. Okay, and so for this one, the answer is no because of part B. We said PW is not congruent to QW. Next one asks, let me find a different color here. W is the midpoint of TV. Yes, it is because I have TW is congruent to WV. That's marked. So yes, okay, TW congruent to WV is marked. Okay, and that's what midpoint means. It means it's in the middle, so my two halves are congruent. Vertical angles. So vertical angles are congruent. That's a theorem. And so if I have the angle 1 and angle 2 and angle 3 and angle 4, those are angle 1 and 2 are congruent to each other, and then 3 and 4 are congruent to each other. So let's do a proof of this. So a proof is something to convince you that a statement is true. Okay, so what we start with is we know that, and we are given, okay, we're just going to do it for one set of them. Let's do angle 1 and angle 2. Angle 1 and angle 2 are vertical angles. Okay, so what does it mean to be vertical angles? Well, it means they're across from each other. And if I look at the picture, I can see that 1 and 4 are a linear pair, and 2 and 4 are a linear pair. Okay, and that's from my picture. So angle 1, so this is my first step, angle 1 and angle 4 and angle 2 and angle 4 are linear pairs. Okay, and I know that by the picture. All right, my next step. So what does it mean to be linear pairs? Well, we know linear pairs are adjacent and supplementary. So that means the measure of angle 1 plus the measure of angle 4 gives me that 180 degrees since they're supplementary. And same thing with the measure of angle 2 and the measure of angle 4. Okay, and we got that by the definition of linear pair. Okay, since they're supplementary. Then if I look at this, well, if they're both equal to 180, I can set these two things equal to each other, right? So measure of angle 1 plus measure of angle 4 equals 180, which is the same thing as the measure of angle 2 plus the measure of angle 4. Hey, cool. I have the measure of angle 4 on both sides, so I can subtract that. And now I'm left with measure of angle 1 equals measure of angle 2, which means that they're congruent, right? That's what congruent means. They have the same measure. So my last step would be angle 1 congruent to angle 2. All right? So a proof, we're going to get into proof details more, but this is just kind of what it might look like to prove a statement is true. Okay? We're going to get into more formal details of that later. You don't have to worry about it yet. And example 5, last example of the day. Find the value of x. Well, if I look, these are vertical angles, and we just proved that vertical angles are congruent. So I can say 4x equals 3x plus 35, subtract 3x from both sides, and I get x equals 35. Now, it's not x equals 35 degrees because x isn't an angle. X is a variable that represents part of the angle measure. And that is all I have for you today.